So today we're going to be introducing the focus and the directrix. Now just a disclaimer, the band has chosen to decide to practice at this time, so we're going to have some musical background to our normal lesson. Don't get too distracted, but just letting you know what's going up if you hear some music going on. Now the focus and the directrix, this is part of a section called conics. And the idea is that when we look at parabolas and when we look at things like circles, ellipses, and hyperbolas going forward, they all have something in common. Now this is going to be best shown before we actually begin and start graphing it as a brief aside. So with conics, it's based off the idea that if I take two right-hand cones, I can create any of the conic shapes. If I take these cones and I cut them directly in half, I'm going to end up creating a cut that when I look at it is a perfect circle. If I take that same cut and I cut it at a little bit of an angle, let's cut it down just a little bit, not too much, I'm going to end up creating an elongated circle, and an elongated circle is called an ellipse. So my two cuts where I'm going straight across are a circle and an ellipse. And then one of the other things, if I continue to increase that angle, let's increase that angle just a little bit further. If I cut it like this, what I end up creating, that's the back end, that's the front end, is end up creating a parabola. And if I cut it very, very, very extreme, if I cut it from the top and from the bottom, end up creating what we call a hyperbola. And the neat thing is that elemental forces like gravity, they work in all of these shapes. So there's a lot of theory when you start getting into the higher maths that when you start hearing about the shape of space and the curvature of space, there's the idea that space-time is conically shaped because gravity always seems to be operating either in a circle, an ellipse, parabolas, or hyperbolas. And this idea is what we're exploring today. We're going to be cutting a cone at such an angle to where we're going to be finding points around a focus. And now the focus of a quadratic is the central point where all points are bent. The directrix is the line beneath or above the quadratic that is equidistant from the parabola as the focus. So what's going on is the fact that if we give you 3 points, if I give you a vertex, this vertex is going to be curved with a parabola. And if I give you a directrix, let's draw my directrix of y equals -1, and I draw my focus of 0, 1, any point along the parabola, it's going to be the same distance from that point to the directrix as it is to the focus. And we can see with this first one, the distance between the parabola and the focus is 1, between the parabola and the directrix is 1. So those two lines are equal. And as I extend out, I'm just going to draw a really rough shape. I know that I can measure the distance at any point. If I say, hey, I want to find the distance between this point right here and the focus, it's going to be the same thing as the distance between that point and the directrix. And this is going to tell us how the parabola is bent, in essence, how close it's going to get to that center point. Again, if we look at this in terms of physics, if I have a comet coming in, the curve of the comet is telling us how close to the planet or how close to the star that comet is going to pass. If the comet is passing very close to the star, it's going to pass really close. It's going to be very bent in that area. The further away, the more gradual that curve is. So every point along this curve is going to be equidistant from the parabola to the focus, from the parabola to the directrix. And this, without even having an equation, is going to tell us just kind of how to sketch a rough graph. There we go. So I notice that these two distances are equal, and these two distances are equal, top and the bottom distances are equal. So let's take a look at one more. If I have a vertex this time, so I'm going to give myself a vertex of 0, 2. Actually, I'm going to make these by 2's just so I can squeeze them all in. So 2's and 2's. I'm going to put my vertex at 0, 2 because I'm counting by 2's. My directrix is going to be at -4. And so what I notice is that my vertex is farther away from my directrix, which means that if I'm thinking about this in terms of like a comet path, I know it's going to be farther away from the planet or farther away from the origin. In fact, it's going to be, in this case, 2, 4, 6 units away. So 2, 4, 6 units up, I'm going to place my planet. And then as I curve the path or the projected path of my comet, realizing that again, it's farther away from the planet, so the curve is going to be more gradual. It's going to be flatter than this one. I know that the distance from here is going to be just over 3, is going to be the same as the distance right here. Which, as we can tell, this isn't quite the same, which means my curve needs to be a little flatter. Unfortunately, I drew this in pen, so I'm just going to have to kind of make up for it by kind of extending that out a little bit and then curving some more. And so if I test this point farther out, 1, 2, 3, 4, 5 blocks, 1, 2, 3. Those aren't equal. So let's kind of ignore this right side. I know that this curve is too steep. I'm going to have to curve it much flatter. Yeah, so again, we're ignoring what's over here. I drew it in pen, I can't erase that. But what I can do is I'm going to draw this curve much flatter so that when I test a point, so about 3 units away, that checks out. Let's see, this is about 4 units away. That is about 4 units away. That part checks out. So again, we're going to ignore the side over here because the two distances were not equal. The curve is going to be flatter than that. And then also, if you really wanted to, I could label my focus of, let's see, 2, 4, 6, 8. 0, 8. That means my planet is located at 0, 8 if my path is going through the point of 0, 2. So with this one, I have the vertex and the focus, but I don't have the directrix. So I know where my planet is, but I don't have the line of which I know my path is going to be bent towards. So I'm going to put my vertex, which in this case is at 0, 0. And my focus this time is at 0, 1. And so I know that if my distance between the two is going to be the same between my vertex and my focus, it's going to be the same between my directrix, which is going to end up at -1. Perfect. And so that's going to give me a point of which I can figure out how the curve is at every point. And so a quick way to check this is I know that, okay, at this point I'd be 2, and at this point I would be 2 away from both of them. which means I know I'm going to be curving through right there. And if I tend to follow that curve as I best can assume, I know the fact that this is going to be a little over 3, and this is going to be a little over 3. Again, my two lengths are going to be roughly equal. That's going to tell me that we're drawing a good rough shape of a parabola. There we go. Might be a little too steep on this end, but again, it's just a sketch. So why don't you try this time? If we've got the directrix and we got the focus, see if you can't figure out where the vertex is, and see if you can't map a path between the two as if you're projecting a course between them. Unpause the video when you're done and see how you did. Okay, so I have a directrix of y equals -2. So I have my directrix down here of y equals -2. And I have a focus of, well, this time it's 1, 0, so it's shifted off to the right. Okay, well, it's not directly centered up, but that really doesn't matter. What I need to know is that directly between these two is going to be my vertex, which in this case, 1 unit away from both is going to be at 1, -1. And so what I'm going to do is I'm going to try and find a point that's about the same units away as it is up. So I know at this point I'm looking at, let's see, yeah, again it's about a 2, 2. So I'm going to put a point right here because we know that I have about a 2 unit and about a 2 unit distance. So I'm going to curve this thing through right there. I'm going to keep curving, so if I want, let's see, if that's a little over 3, I'm going to be a little over 3. So let's put another point right there and curve through it, which again, if this is a little over 3 blocks, diagonally that's a little over 3 blocks, we've got a good sketch going, which is going to allow us to figure out what the overall shape of the graph is going to look like. Perfect. And same thing right here. No matter where on the graph it is, now this focus is at 4, -5, so I'm going to do this by 2's. I have a directrix at -1, and I have a focus at 4, so 2, 4, -2, 4, 5. Oh, here we go. So we have our first upside down parabola. Now I know my vertex, again, is going to be directly between these points. So what's directly between -1 and -5? Well, it's going to be -3. And because I know it's going to be lined up with my focus, I know that that is going to be directly for -3. And again, we're just going to try and find somewhere that's kind of equidistant between the two. So if this is 2 units and this is 2 units, let's see, if I'm about 2 units away, I'm 2 units up. So this 2, 2 seems to be a good spot for us. So I'm going to go 1, 2, and I'm going to go 1, 2, which means I have a point that's curving right here, which means if that's 1, 2, about 3 away, I'm going to be a little over 3. So let's keep curving just like that. Which is going to be just over 1, 2, 3, and just over 1, 2, 3. And then I'm just going to mirror that. See, 2 units away, 3 units away. There we go. And there's our vertex and our directrix.